Hi guys, welcome back. Today we're going to be going through Gaussian elimination. So I'm going to do this using a 2x2 matrix and a 3x3 matrix, and I'm just going to show you how to do this by hand. So before we get started with the process of Gaussian elimination, there's a couple of things that we need to know. And the first thing that we need to do is that we need to create an augmented matrix. So you can see here what I mean by the augmented matrix. We take our coefficient matrix and we place it next to our value matrix. Once we've done that, the next thing that we are going to do is we are going to perform one of three different elementary row operations. The first of our row operations is that you may swap any row. So remember, each row represents an equation, so it doesn't actually matter where in the augmented matrix it is placed. The second elementary row operation is that we can multiply any row by a scalar value. So for example, we could take row 1, which is 5, -2, and 8, and we could multiply that whole thing by 2, and it won't impact the outcome of our answer. Lastly, we can add any row into another row and replace that row. So now that we've got our three elementary row operations, there's two goals or two different ways that we can set up our matrix for elimination. So the first way that we can do this is called the row echelon form. So when we have row echelon form, effectively what that means is we'll have a diagonal of ones. This lower triangle will contain a 0 and this upper triangle will contain some value. And then we'll have our answers or our outputs. So this is called the row echelon form. The other way that we can do this is to completely reduce this so that this part here contains the identity matrix. So this is called the reduced row echelon form. And this looks like the identity matrix on this side, and then we'll have our two solutions on this side. So each of these have their own advantages and disadvantages. The reduced row echelon form does take a little bit longer to do. And the row echelon form may be a little bit easier because you can use back substitution to solve for the remaining variables. So let's have a go and let's try an example using this Gaussian elimination method. So probably my most important tip when doing this is I would actually suggest trying to get this diagonal of ones first. So what I'm actually going to do is I'm going to attempt to manipulate this value here until it's a 1. So to do that, what I'm going to do is I'm going to multiply row 1 by its reciprocal, so 1/5, and I'm going to replace that into row 1. So I'm not going to do anything here with row 2. So now that we have this 1 in the top left corner, it's going to be a lot easier to manipulate the rest of the rows. So I'm going to kind of do a 2-in-1 step here because I don't want to alter this first row. I like the fact that I've got my 1 here. So what I'm going to do is, in order to get this value here, the 3, into a 0, I'm going to multiply this by -3 and then add it into this row. But again, I'm just going to do this in one step and replace row 2. I'm not actually going to change row 1 at all. To show you what this looks like, so we're not going to change this top row. That's going to stay exactly as it is. So what we're going to do, so 1 times -3 plus 3 is going to be 0. -3 times -2/5 is going to be 6/5. 6/5 plus 4 is going to be 5 and 1/5. And then we're going to do the same thing here. So 8/5 times -3 is going to be -24/5 plus 10. We can start to see that we're nearly at the end now. So what I can do is I can divide this row by 5 and 1/5, and that's going to give me the diagonal of ones that I want. So we're starting to get close to the end now. So this is in what is called row echelon form now. And since this is in row echelon form, we can go ahead and we can finish solving using back substitution, or we can continue to mess around with the matrix until we get the reduced row echelon form. So to start with, I'm just going to show you the back substitution method. So when we do a back substitution, remember that this column here corresponds to our x values or coefficients of x, and this here corresponds to our coefficients of y. So this bottom row here, we have 1y is equal to 1. This row here, we have 1x minus 2 over 5. Y is equal to 8 over 5. And since y is equal to 1, we can substitute that into our value here. So rearranging that equation, we're going to get x is equal to 2. So that's one way we can solve, and again, that is using back substitution. I'm going to show you now using the reduced row echelon form that we do actually get the same values. So to continue with our matrix from before, I can see here that I've almost got the identity matrix in this section here. So to do that, what I'm going to do is I'm going to manipulate this value here. So I'm going to multiply this by 2 over 5, and I'm going to add it into this row. But I won't change this row here since it's already in the form that I want. So to repeat that, we're going to do 2 over 5 times by row 2 plus row 1, and that's going to replace into row 1. So I'm just going to leave this bottom row as it is. Now, if we did 2/5 times 0, that's still 0. 0 plus 1 is 1. 1 times 2/5 is 2/5, plus negative 2/5 is 0. Fantastic, that's exactly what we want. 1 times 2/5 is 2/5, plus 8/5 is going to make 2. So we can see here again, this is my column of x coefficients, this is my column of y coefficients. So we have 1x is equal to 2, and we have 1y is equal to 1. So either way, we end up getting the same values. I actually prefer using the reduced row echelon form. I think it's really fun to do this matrix, this Gaussian elimination with matrices, but some people prefer the back substitution method. Let's have a look at one more example. This one's going to be a 3 by 3, so a little bit more complex. So the first thing I'm going to do is I'm going to set up my augmented matrix. So I'm going to take all of the coefficients and I'm going to take the value matrix at the end. So here we've got our x coefficients, 5, 2, and 1. Then we have our y coefficients, 2, 5, 3. And then we have our z coefficients, -2, 3, and -4. This is then our value matrix over here. So we have 2, -8, and -11. So again, to start with, what I want to do is I want to make this top value, I want to make this 1, so I can start my diagonal of 1s, and I want to get my lower triangle of 0s here. But I can see I've already got a 1 in this position. So what I'm actually going to do is I'm just going to swap those two rows over. Now that I have a 1 in this top row here, I can use this value to manipulate or change these two values here. So what I'm going to do, I'm going to work on this row first, and then I'm going to go ahead and move to row 3. So to do this, I want to keep this 1 in this top row, so I'm not going to manipulate this first row at all. That's going to stay how it is. But what I will do, I'm going to multiply this by -2 and then add into and replace row 2. So to show you how this works, -2 times 1 plus 2 makes 0. -2 times 3 is -6, plus 5 is -1. -4 times -2 is 8. 8 plus 3 makes 11. -11 times -2 is 22. 22 minus 8 is going to be 14. Okay, so we can start to see now we're developing our zeros. So let's continue on and do the same thing except with row 3. So this time we're going to do -5 times by row 1, adding that to row 3, and we're going to replace into row 3. So 1 times -5 plus 5 is going to be 0. 3 times -5, -15. -15 plus 2 is -13. Last one, so -5 times -4 is going to make 20. 20 and -2 is going to make 18. And then -11 times -5 is 55. 55 plus 2 is going to make 57. All right, so we are starting to see here, we've got this full of zeros, which is exactly what we want. So now we can move on and we can continue to work on this diagonal of 1s. And as we can see here, this is pretty close. All I need to do is multiply row 2 by -1. So we'll just continue to repeat that process. And again, now that I've got a 1 in this column here, I can use this one to manipulate this row here. So what I'm going to do is I'm going to do positive 13 times by row 2 plus row 3 and replace that into row 3. And again, I don't actually want to change this now that it's in a form that I want. So when I multiply and add this in, it's just replacing this last row. So starting off here, we've got 0 times 13 is 0, plus 0 makes 0. 1 times 13 is 13, plus -13 makes 0. So we're getting our lower triangle now. -11 times by 13 is going to be -143. And then -143 plus 18 is going to make -125. All right, the last one here. So we've got -14 times by 13, which is -182. And we're going to add 57, which again is going to give me -125. All right, we are almost there because look what we have. So now I can just go ahead. I can divide this whole row 3 by -125, and then I will have my diagonal of 1s. So since we have our diagonal of 1s, our lower triangle of 0s, we now have the row echelon form. So we can go ahead and we can use the back substitution method to find the rest of the values. So we know that 1z is going to be equal to 1. Looking at this second row here, we have 1y minus 11z is equal to -14. And since z is equal to 1, substitute this into here. Y minus 11 is equal to -14, and so y is equal to -3. Okay, so then again, we can write our first and final equation here. So we have 1x plus 3y minus 4z is equal to -11. So we know that z is equal to 1, and we know that y is equal to -3. So this is going to become x minus 9 minus 4 is equal to -11. And so x is equal to 2. Okay, so there we go. We have our solution for our 3x3, and that's using the row echelon form and back substitution. So if we wanted to continue, we could totally continue with this using the reduced row echelon form. And now that we have this diagonal of 1s, it makes it a lot easier to manipulate the rest of these equations. Because using this value here, if I go -3 times this row, add it into this row, this is going to remove this term here. Same thing, I can use this one to manipulate these two rows here. So I'm going to go ahead and I'm going to multiply row 2 by -3, and I'm going to add that back into row 1. So -3 times 0 plus 1 is going to make 1, so that's going to keep my 1 up the top there. 1 times -3 plus 3 makes 0. -11 times -3 is positive 33. 33 minus 4 is going to be 29. Okay, last one, we have -14 times by -3, which is equal to 42. 42 minus 11 is equal to 31. Okay, so now we've got this 0 here. We can go ahead and we can repeat this process using this last little one here now, and that one can be used to manipulate these two rows or these two elements here. So let's do row 1 first. So we can do -29 times row 3, add that into this row, and that's going to remove that term. All right, 0 times -29 plus 1 is going to make 1. Again, same thing, that's going to make 0 there. All right, so now we have -29 plus 29 is going to make 0. All right, same thing again. 1 times -29 is -29 plus 31 will make 2. And I'm fairly sure this is the same as what we had for our solution before. Ah, yes, here, I can see it here. All right, so now we just need to do our final little row here, which is going to be row 2. So again, to do this, I'm going to do positive 11 times by row 3, adding that into row 2, and I'm going to replace row 2. So since I'm replacing row 2, I'm not going to alter this bottom row here or the top row. So these bottom rows and these top rows are now considered to be solved. Okay, 0 times 11 plus 0 makes 0. 0 times 11 plus 1 makes 1. 1 times by 11 plus negative 11 makes 0. Then we have 1 times 11, so 11 plus negative 14 is going to make negative 3. So now we can see this is my x column here, this is my y column here, and this is my z column here. So we have 1x is equal to 2, 1y is equal to negative 3, and then we have z is equal to 1. So we end up getting the same values as we did before. So that's how we use Gaussian elimination to solve systems of equations. So I've done using a 2x2 and a 3x3 today. So the biggest tips that I can give you to solve these are to find your diagonal of 1s first, use those to create your lower triangle of zeros, and then you can either use back substitution or you continue to use the row operations to solve the matrix. So there you go. All right, I'll see you in the next video.